So we have established our 2D adaptive clearing tool paths, two of them, to get the pocket material inside here cleared out and the outer profile roughed out and cleared. Now we're going to come in here and do what's called a finishing pass to complete these. So my tool carousel is rather limited on the vertical machining center we have. We only have 10 total tools, one of which is our probe. So we're a little limited in the number of tools that we can use. If you have the tool carousel capacity, you may actually want to use different tools than the ones we use to rough. But in our case, we are going to be sticking with the same tool that actually roughed the operation before. It's going to also be the finishing tool. So here we go. We've got here is the flat 3/8 inch diameter end mill. So that is selected. That is the correct one. What we're going to do now is come to here to geometry. And again, we're going to select this pocket selection here, that chain right there. Now heights, same deal. Don't have to alter much there yet, but we'll see what difference this makes, what we might want to do after we simulate it the first time. So now we're on the passes tab here. Here's where things are going to get a little bit more interesting. We need now to select finishing passes. Now once you select finishing passes, maybe a little foible here with Fusion 360, it adds in an option above where you just clicked off up here for this compensation type. This is going to be really important that we're going to want to take advantage of this. We're going to come down here where it says in computer for compensation type, and it talks about what this is. But what we're going to want to do here is select off where. Okay. And then it's going to give these other things. I'm going to allow the compensation radius to be okay there. Finish, we're not going to alter anything here yet. So number of finishing, we could leave this as 1 for right now. Step over, 37.5 thousandths. Okay, sure, fine. Leave that as is right now. We'll leave off the repeat finishing pass for now. We can come back and see that later. But what we're going to want to make sure that we do is deselect this stock to leave right now. If we leave this checked, we're not actually going to really remove any material so much that we did before. But we actually want to finish out right here. Again, we'll leave multiple depths off for right now. We can see that later. We do that. But here we go. Linking parameters. Not really changing much in here yet. Excuse me. Zoomed in and out. This dialog here. So here we go. We're going to click OK now with all of that stuff that we've entered in. It has now created this tool path. Now if we simulate this whole thing and play, I'm going to jump to the next tool because I'm not really concerned about this. We know that this is clearing out that pocket. I'm going to jump to the next one. Now we're clearing out the outside that we did on the other operation. Now here I just jumped into the finishing operation. So what we're doing right now is we're helical interpolating down, but the thing that comes to my attention is we're helical interpolating down, taking our time getting down through material that isn't there anymore. That's just air. It had been roughed away. So that's one thing I'm noting that we could do better. Now we're hitting the floor and we're walking around, coming around to finish out the floor of the pocket, and then now that's doing the the walls of the pocket all at once. Okay, so I'm definitely seeing that there's some improvements we can make. So in terms of just basic optimization, this is wasting us a lot of time by coming down here, round and round and round through air. We're cutting air. That's not a good thing. So what we're going to want to do here is come back to 2D pocket. We're going to want to edit that. Now, knowing that we removed all this here, if we come back to heights here, so top height here now. So this is from top height sets the height that describes the top of the cut. Top height should be set above the bottom. Top height is used together with subsequent offsets to establish the height. So instead of doing, right now it's coming from stock top, which if we were to look at this here, stock top was somewhere, what that's referring to is the stock that we had created in our setup here. That's way somewhere if we were to look at the front of this thing. Compared to everything else, that stock top is going to be somewhere up over there, is where we're starting our whole interpolation coming down. Now, so instead of doing that, what we could do is from our selected contour, where we had selected the operation to begin. Now this would be hazardous if we left it this way. It would come all the way down and then start cutting. It would just literally plunge into the part. But say we knew that we were leaving 20 thousandths of stock on the floor of this, just to give ourselves a little bit of room. From the selected contour, we can make this 0.030, 30 thousandths of an inch above the bottom of where we're going to finish out to. And now if we click OK, and we cursor around here, look at that. We started a lot more effectively lower down in the bottom of the pocket. Now the other thing too here is it's taking kind of 1, 2, 3 loops around. Depending on the tool that you've got selected here, I'm going to come back and edit. And I'm doing this just to show that we can alter and change these things to optimize a little bit more. So what we want to come into here is under linking parameters, down at the bottom here where it says ramp. Now we've got ramp type is set to helix. We can either plunge, that's just straight down. Predurl is if we had a hole or something else that we had created, we could come down into that. Zigzag is moving linearly back and forth. Profile is going to be following the actual profile of the outer edge to come down. Smooth profile I think is going to do, yeah, you can read those a little bit more carefully. But we can leave it at helix right now. That's just simply going down in a helical fashion. Now instead of leaving it at a 2-degree ramp, we could actually crank this up, say a 3-degree ramp, and see how that changes. I'm going to click OK right now. And now instead of 3 full passes around, it's just taking a little less. It's doing it. It's going to come down a little bit faster. You can make it steeper depending on the tool you actually have, or if it's center cutting, or for this small amount that we have, we could actually change this to be a straight plunge if our tool was center cutting, which the one we are using is. Though it may not leave the best surface finish on the bottom of the part either. You could get some witness marks there. But these are all things, depending on what your operation and how much you really have to optimize or cut time out of a process, these things very much can end up mattering. But that's then how you can start editing those things to make the tool paths much more close to your desired optimal. So again, if I step through all this, come back and take a look. So now that's coming down a lot more effectively, a lot faster to then remove that material out of the pocket, or excuse me, finish out that pocket. Okay, the last things here in terms of quality of this that I'll cover, if I come back in here and edit, it's a very subtle thing, but where this tool was entering in on this profile and where it was exiting the last time was at the same point. Now the other thing that you can do here related to passes that can help to improve the quality of the cut that you get in the end is, one thing is repeat the finishing pass. So depending, this is what's taking colloquial that is known as a spring pass. So it's literally going back over this, it's not changing at all on the very last time around this part that it goes. So it's doing the same one again. So repeating that. And this other dialog here is finishing overlap. So this will allow the tool to not just start and stop at the same point, but say go 100 thousandths beyond where it started. What this can help you do is make sure that you don't get a little witness mark where you actually enter in and exit each time. So as a best practice, it's usually kind of good to do that as well. So now what's going to happen is if I simulate again this whole thing, and I'll jump in to the last. We'll come back on that one. Hit play. We'll move this up a little bit. It's going to finish the floor of the pocket out. It's going to come around once. It's going to go back around again. And if you had noticed where it's a little difficult to see, but where it had entered in on this wall, it's actually exiting 100 thousandths further down to the left there. So that helps to smooth out the wall and give you a better finish on that wall ultimately. So that's the end of that pocketing routine.